If you haven't downloaded the MicroCap10 program, look at Diode Decimal to Binary Decoder Tutorial 1 for instructions. Tutorial 5 is one of many circuits using the 555 timer IC. It generates a series of pulses whose pulse width and time between pulses is related to resistor and capacitor values. It is a great IC to experiment with. Print a copy to refer to when you build this circuit. Make note of the node numbers shown in red. Node 7 is the capacitor discharge voltage, and node 8 is the output pulse. We go to the transient analysis option to see this circuit in operation. Make note of the box settings. The time range is going to be 5 milliseconds. We have graph 1 and graph 2. V7 is in the time range of 5 e to the minus 3 starting at 0 and 2 to the e minus 4 steps. The voltage range, and this is for both graphs, is 6 volts peak starting from 0 volts in 1 volt increments. So now we'll run. And there you see the discharge of the node 7 point, and you see the output pulse. So we will exit the transient option, and this is a circuit that we're going to build. We will call in the operational MicroCap10 simulation circuit. As usual, we have to get rid of the tip of the day. We have to go in and put in our grid. Then we start going for parts. What we'll do is we will look for the 555 timer. That's under macros. We bring it in and place it. We're going to accept it. We'll escape from there. We're going to start adding resistors. We'll select a resistor here. It's in the wrong orientation, so I hold down the left mouse button and click the right, and then I bring it over and set it in position. This resistor I'm going to make 1K. The next resistor is going to be 150K. I'm going to get a capacitor. I will place that, and I will make that one 0.01 microfarads. I will need another capacitor. I'll make that one 0.01 as well. I'll need a voltage source. This time I'll do a battery. And I'll make that battery 5 volts. I will escape from that, and I will go for a diode. Select diode, general, one N 4148. That is in the wrong orientation, so left click and right click. Again, finally I have it in the right orientation, and I put it in place. And we are set for some wiring. I will do a few wires, and then I will just go ahead and wire everything up, so you don't have to wait for all of these things to be done. I click, hold, and release, click, hold, and release. That's the typical way wiring is done. There you see the wiring completed. We have not added the ground, so I'll click on the ground icon, bring it over and place it there, place it there, place it there, and escape. So we're ready for transient analysis. We go to transient analysis, and we see that this is set for different times. We will make some changes. We want 3 graphs, so we'll make that a 2, that a 3. It turns out the node numbers are different, so this becomes 3. And this becomes 4. I was wrong about wanting 3 graphs. That's not the case. So we'll move this up. Over on this point, we're going to change this time, and we're going to make it 5 times e to the minus 3 and 0 and 2e to the minus 4. And over here we're going to make this 6, 0, and 1. I filled those two in. There was no need for you to wait for me to do that. This has to be changed to 5 milliseconds. And we want to uncheck the operating point box. So now we'll run. Something's gone wrong. We'll go back and look at the circuit. A ground got left off, so we go up to get the ground signal, bring it back, attach it. Now we'll go back and do the transient analysis. And there we have our output. Get out of the transient analysis, and this is a circuit that's operational. You can play with the values. It will be a fun project to see how the various resistors control the time interval and the pulse width.